My name is Shlok Shah, and today I will talk about mathematics in nature. These are the topics which I'm going to cover in my presentation today. Have you ever noticed different patterns and structures in nature? The phenomenon of various patterns, structures, and principles that naturally occur explains mathematics in nature. From the smallest particles to the largest celestial bodies, it can be understood and described using mathematical concepts. Throughout my research, I have come across some truly fascinating examples of mathematics in nature, and today I'm excited to talk about one of them, spiral, particularly Fibonacci spiral. So what is a spiral? A spiral is a curve which emanates from a point, moving farther and farther away as it revolves around the point. Spirals are a common geometric pattern found in nature and have different types. Here are some examples. Before I continue about the patterns found in nature, let me introduce the Fibonacci sequence and golden ratio. The Fibonacci sequence is a set of numbers in which each number is a sum of the two preceding ones. It starts with 0 and 1, and then each subsequent number is the sum of the two previous numbers. For example, 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 2 is 5, and so on. So the sequence goes 0, 1, 1, 2, 3, 5, 8, 13, 21, 20, 34, and so on. The golden ratio is a special number that describes the relationship between two quantities, where the ratio of the smaller quantity to the larger quantity is the same as the ratio of the larger quantity to their sum. This ratio is approximately 1.618033988875. It is often denoted by the Greek letter phi. There is a special relationship between the Fibonacci sequence and the golden ratio. When we take any two successive numbers, one after the other Fibonacci numbers, the ratio is very close to the golden ratio. For example, 3 by 2 is 1.5, 5 by 3 is 1.666, 233 by 144 is 1.6180, and 377 by 233 is 1.6180, and so on. In fact, the bigger the pair of Fibonacci numbers, the closer the approximation. Interesting, right? Where can you find spirals? Spirals can be found in our DNA, floral patterns, snail shells, pine cones, galaxies, spider webs, fingerprints, hurricanes, horns of various animals, pineapples, and many more. Pine cones are hard structures, which are usually cone-shaped, that protect the reproductive parts of pine trees. Each scale of the pine cone has one seed going near the center of the cone where they all connect. What type of pattern can be found in pine cones? Pine cones have a distinctive pattern that can be observed on their surface. The pattern consists of a series of spirals that run in opposite directions, starting from the base of the cone and spiraling upward to the top. Fibonacci sequence in pine cone. Fibonacci sequence in pine cone.
This is a pine cone. There are two kinds of spirals observed on the pine cone. One spiral goes clockwise, while the other goes counterclockwise. Let's count the highlighted spirals on this pine cone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 spirals clockwise. Let's count the highlighted spirals on this pine cone. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 spirals counterclockwise. In this pine cone, we can see both directions of spirals highlighted in green and blue color.
Fibonacci. What do you think? Is this pine cone symmetrical? The pine cone pattern is not perfectly symmetrical in the sense that it does not have identical parts that are mirror images of each other. In other words, the pattern of the scales on a pine cone exhibits a kind of rotational symmetry. which means that the pattern looks the same when you rotate around the central axis. However, it is not perfectly symmetrical in the sense of having identical parts that are mirror images of each other. How does the spiral pattern in pine cones help? The spiral pattern in pine cones allows for optimal spacing of the scales, which help to ensure that the seeds are evenly distributed within the cone. The spiral arrangement of the scales also provides a secure and compact structure for the pine cone, protecting the seeds from damage and predators. So the Fibonacci sequence in pine cones is not just a beautiful pattern, but also a functional one that helps ensure the survival and propagation of the pine tree species. Isn't that cool? Here are some fun facts. Fibonacci series is named after the Italian mathematician Leonardo of Pisa, who is best known as Fibonacci. November 23rd is the day of Fibonacci because the numbers are in the Fibonacci sequence of 1, 1, 2, and 3. Fibonacci sequences are used to search a sorted array in the field of computer science. Fibonacci was not the first one to know the sequence. It was known by India years before. These are the references for mathematics in nature. I hope you had fun learning about Fibonacci sequence golden ratio in pine cones. Thank you!